is Marton, who works at Re. Is it Re.net or just, no, it is .net. Yeah, Jesus Christ. Just have to remember this stuff. Oh my God, he's got like more Stack Overflow points than all of my friends put together. By at least a good factor of 10. Jesus Christ. Okay, so it appears he's very, very active and very, very helpful for people. So I'm assuming you're going to want to ask questions at the end of this. I believe you're going to be talking about BigQuery on ML.
Indeed.
So, yeah, machine learning.
Hi there. I'm Marton. I'm coming from Kodok, City, and I'm actually very active in the community itself. You know Stack Overflow. I'm top 3 there, so they are better than me, but I have 133,000 and counting reputation points answering probably your questions. And I was appointed based on this Google Developer Expert, which is the same as the Java Champion or MVP. And I'm close with the Google Technologies. Today, I brought you a new topic. You may see in the previous editions of that talks different topics, but this is actually brand new. It's like 3 weeks on the market. And I will talk to you today about machine learning, but machine learning using CQL. Who in the room can write a select statement in the CQL work? Great. That's great. So I won't talk about too much theory today because I know that machine learning theory is either too scientific or it's too boring. So I'm a developer, so I want to showcase you what developers do and how we do the things. We at Rea, we are using the Google Cloud Platform to actually run our projects. And if I were to add here slides, it would be like 400 services which are on Google Cloud Platform, and they are evolving from every month with new services and so on. I need to mention that Google is doing a lot of managed services, and nowadays they are doing hybrid cloud as well. With the Native Initiative and ANFOS, you may have read about the announcements from the Cloud Next conference, which was like 2-3 weeks ago in San Francisco. Of course, if we see that do you hear me? Do you hear me? Okay, fine. So what was the last thing that you heard? Good, I will keep continuing because you didn't argue anything. So I will go quickly about this slide, is that if you need to understand that managed services are actually APIs. And that means that very simplifies the way how we use technology nowadays. And you don't need to have ops, and the ops is actually minimized. Of course, there is, we can have an assumption that it lets you to focus on the code, it lets you do event-driven. It was explained in the previous session what does that, and it's stateless. Let's go forward. So serverless, just one single slide to have a global context from it. Serverless nowadays is not just functions or Lambda functions, whatever how you call it. It's all kind of services, even from storage to cloud tasks to message queues, and even Stackdriver, which is the metrics interface, and BigQuery as well. And I will talk about BigQuery from that chart later, but we will see that the serverless is actually adding us more cost, agility of cloud computing, and it maximizes the elasticity. Serverless are two types. One is triggered code, one is platforms. If you want to see the triggered code, it means that at some point there is an event triggered, which is happening, that's launching my function, and I have a result for that application. You need to observe on this chart that I added here that this section is in the cloud, the other section could be out of the cloud, could be on-premise, hybrid cloud, or could be also inside the cloud as well. Okay, and managed services. So this was the triggered platform and managed services, and BigQuery. Now, what is BigQuery? So BigQuery is actually a Google product, and it's an analytics as a service. And I say that it's a hidden gem in the cloud vendors because it has a very, very good payment model, which is actually unbeatable on the current market. As you can read, it can scale up to petabytes. It's no problem to build a huge file, like one single 5 terabytes of file. You can upload it, it supports, it doesn't crash it, it doesn't run out of resources. And my favorites are actually that it has the most modern or up-to-date SQL standard, which means that I have access to JSON functions, advanced JAO, and all the stuff that's not the SQL standard, which is Windows 3.1 era, and now Windows is where. And the other favorite is that user-defined functions. When I write functions, I can choose to write in JavaScript. And this was like in the edition of the early edition of that talks, I mentioned about this. When I found out that I can mix SQL with JavaScript language, that was actually an awesome day. It actually lasted like a week, my joy. And nowadays, BigQuery added machine learning functions to it, and I will talk about that later. Just coming back to the slides a bit, managed service, I need to mention cost. I'm not selling the service, but I need to mention storage is like $20 for terabyte, yeah, and the queries is $5 for terabyte. And you have 1 free terabyte per month free. So if you go home and you check it out for 1 terabyte, you can try this service out. Google has all the services actually connected to the BigQuery. So if you open your projects up to the BigQuery, you will natively get access to other automated federated data, how they call it. It means that you, for example, if you use Firebase, you can have all the events. You just enable the BigQuery extension, all the events exported to BigQuery, or Google Analytics. You need to pay this, but for Google Analytics, you can enable to get all the events emitted to BigQuery, and you can actually join that table that Google Analytics system creates with your table, and you can actually have nice results. And of course, in the other parts, you can use all the tools to actually get out results from the service. Our favorite is that I'm a developer, so I actually sometimes get tasks where the report is very, very small, and I need to spend rudimentary integration there. But having all this in BigQuery, the data analyst or whoever wants to run the report can go directly to whatever tools they run, Tableau and similars, and they can build out the model, and I don't need to integrate it. Of course, the advanced reports we will integrate, but the simple ones, they can do it by hand. The first question arises that we need to pipe to multiple places. Why we need to pipe to multiple places is that often people here in the region don't use the hybrid architecture. So they only do keep the data on one system, and nowadays keeping the data duplicated is it's not a cost model. So you can actually, like with $20 for terabytes, you can keep the same data model also in BigQuery and that. But for that, you need actually an exit from your architecture to BigQuery. And I won't spend too much time explaining this architecture, but pretty much this is the base of an architecture that we at Rea run. So we have all kinds of events from the end devices, that could be actually mobile devices, websites, products, and also system events. We can add the logs, we can collect logs from the system. And we have all this wired into an open source component called FluentD. And FluentD is actually an event router. And I say that, why we need that? We need FluentD because I send it once, and then the FluentD can multiply that and do certain things with that. So one output is that it forwards to us, to our application, so it's transparent. The other is that it wires into the BigQuery service. And the other is that it puts on Google Cloud Storage for archiving. Later I may need an option to replay this data in case that I want to reboot the model and so on. Replaying could be automatically with CloudFunction function and also into the BigQuery. This FluentD component is actually like the code fits in the screen, so you only need to add little logs there, and you set the connectors for the services. The other part, what I mentioned earlier, analysts can quickly do things on the BigQuery side. Half of your problem is already resolved because they don't come back to you with boring stuff. Okay, so if I summarize just BigQuery, so SQL 2011 I mentioned, they have a service with partitioning and clustering. This is actually when you reach into the several terabytes of data. Often BigQuery folks who work with data, they have one single table, multiple terabytes of data, and it's no problem to actually trash in there a lot of data, and they actually can filter out with partitions. This is naturally implemented, so you don't need to keep up indexes, you don't need to vacuum it, so this is managed service for you. You just write a query for it. Because BigQuery is very cheap, we actually throw in all kind of data. Developers often ask me, what should I put in the log message? What should I send in the BigQuery? And I always say, send all the variables. Because you don't know when you need that. And we have a special system for that. We have columns, and we have a meta column where we actually turn all that into, which is not fitting in the column in a JSON, and we keep all the data there. Why? Because anytime I can use a JSON function to actually get out a variable from that meta JSON and rematerialize that term as a column in the database. And that's very cool to actually build out reports from the old data. Inspiring ML function, this will be developed, and no running a lot of resources. So for example, when we had Spark era, we actually started up running integration. Kicking the process, it ran 6 hours, and it said out of heap space. I Google Stack Overflow, I tune some parameters, it runs again for I don't know how many hours, a little bit longer, out of heap space. So you see smiling, probably you've seen this common in your Overflow, but when you have a managed service which is like an indefinite scale, you don't have this kind of problems. And now the topic. Sorry for warming up a bit, because often people don't know what BigQuery is in this audience. So, machine learning. And the magic is that you can have create model in the SQL syntax. And that's it. From there, it's all just adding little parameters. You don't need theory, you don't need anything. And what you can do then, so you can execute machine learning initiative. So initiative is a good English word here, because this is actually just launches you on the machine learning, train. And actually you could outscale this model if you are very good at what you do. So I'm not saying that it replaces TensorFlow or something like that on deep model, but if you want to kick in machine learning at this phase, with all the features that BigQuery ML has, it's like a half-day integration, and you have a machine learning model in. Because SQL, everyone knows, the syntax is easy. It increases development speed, of course, because we don't need to spend 3 months to learn TensorFlow or other similar services. I'm not balancing them, because they are different tools for different kind of problems. And you can have, like, with the one true line of code, you can actually get all the system up. You don't need to spend too much time to actually tune parameters and balance all kind of things. Let's see how this is turning out. So BigQuery team implemented this, and behind they are running all kind of machine learning algorithms. And what's amazing to me here is that this integration was done by a Romanian guy. I met him like 2 weeks ago in the San Francisco conference, and he explained me that the team is actually Epsom, and he is one of the lead developers there. And the behind of the scene things is actually much more complicated to actually have that 2 line of syntax. Of course, we need to mention that tabular data. So what you keep in columns or tables. We can see also for images. I have an example. But often when we talk about machine learning, and there were other sessions in other rooms, they often have it like vision, which is a camera thing, or audio, or imaging, and so on. But let's go back a bit to the tabular data, which we actually have and we own and we keep it, or to run in our businesses. It automatically split the data into tests and actually evaluation and running. So often, big experts in machine learning ask me, how do I create a trained data and how do I create an evaluating model? How do I scope out that the model doesn't see anything and so on? This is automatically built in. Of course, you can tune it. There are parameters which you can actually balance this. But often they do like 80-20% automatically choose only from your table that data, and they build the model from that. And the rest of that is actually used for the evaluating. Also the learning rate. So you will see that we can run like 100 iterations, but I've seen from my experience that in 4 or 5 iterations the model is actually producing good results. And if I get to 20 iterations, they actually flat out the learning rate around 8-9. So I have either option to actually run the iteration or actually to see what the increase in the learning rate is. And the magic is that if you run the model, you of course select it, how you need to predict from it, and actually the results can be joined back with your business table. And this is where actually the business value comes out. It's not a jump data. You can, on a primary key, join back to the product and display, I don't know, that 10 product which you recommended the system. And to have a context for this, Google products here. So this chart is actually too strict for Romania because often we don't have a SQL analyst on our payroll. It's a mixed role, but you can figure out that, for example, TensorFlow is something it's advanced, but AutoML and all the cloud APIs is for developer-ish, so they need to understand how to integrate API. But here in the middle, I say that the people who use SQL can learn and can use SQL models. I would say that you should try out also AutoML. You can Google it. It's a Google Cloud AutoML thing where you can actually just upload a bunch of zip content, and they will automatically run the model on it, and you get the prediction rate. And later, when you upload an unseen item, you get the match for that. No, let's talk a bit technical. So. Linear regression forecasting. I'm actually reading this because I don't want to spend too much time giving the definitions for this, because I want to see how they work in practice. Binary and multi-logistic regression. So binary is something that, is it a cat? It's not a cat. So it's like binary, 1, 2. Cummings clustering, we will see this in a big example, identifying clusters, like let's say, who has television, who has kitchen. Matrix factorization is something that's in alpha, but I will show you what's this in example. You may not recognize from this matrix factorization name what this is, but I will see later. And also nowadays they added the DNN for TensorFlow, and also the TensorFlow models prediction in BigQuery. And this will be the future, because you can actually add a TensorFlow model which you build out from a longer running process into the engine, and you just take the model as a zip file, you name the path where it is, you run the query, and voila. Of course, if you are really interested in getting into these alphas, you can reach out to your Google representative or me. I can forward your request for further to actually enlist you into these alphas. Alpha means that you can try out the service immediately without actually waiting the next big conference when they announce it general available and so on. So, what we have here, if you Google out like getting started with BigQuery ML, you will see an example, this URL, which will actually let you to use Google Analytics dataset, which is actually hits from the website or whatever mobile app or your product, and it predicts whether a visitor will make a transaction based on some data. And what you need to learn for this is to learn how to write a create model, how to write an ML evaluate, and how to write a predict. And I will show you on the screen how to do. I had to prepare screenshots because the internet is not allowing me to run live demo. So I prepared screenshots and hopefully it's readable from the back of the road. So I let people to read it a bit. So what we have on the screen is that we have create model, options, we add the type of the model that we are creating, and the rest is actually SQL, which we know. What we selected here. So we are selected, we need to select a label, because this is the binary, the logistic regression, so it needs to be like true, false. It really purchase, won't purchase, and the training data I need to purchase that who are the customers who didn't have any purchase. And this is actually the total transaction. If it's null, then the label is 0, and otherwise they have a purchase. And otherwise, I'm actually using from the Google Analytics source only the operating system, if it is mobile, country, and how many page views they have for that. I don't have any group bys here for like user or for country. It's a general data set. I added the date interval just to actually emphasize that I'm using data which later it won't be in the prediction set. This ran for 7 minutes, so it's not like that. So creating model is sometimes could span also 6 hours. And it used 23 megabytes like the model. If you have a large data set, of course, it can use terabytes of data and so on. Next query. Actually, you need to run 3 queries, so this is the second one. The second one is actually, I see the results, I want to see out the precision, like from the data that I added into the model, what's the precision for that? The precision is here, it's 46. And of course you say that it's below 50 and so on, but often machine learning models is not like 80, 90%. Usually I say that 65% is something acceptable. Of course, if someone wants to identify that someone has a firearm and walks into a bank, and the captured image should automatically identify if the firearm is there, you need to be quick and silent alarm the security guys. This is a different problem. But here, with the tabular data, we can further tune the system. This is just a minimal example which you can actually run at home, because these tables is a sample, it's a public sample, and you can actually copy this query and type it in, and it will give you the same results. You will have the slides on the SlideShare platform, so if you are actually taking photos, you are allowed to do, but you will have the slides share, the full presentation shared on SlideShare. Now, and next one is actually the query to predict, because the previous one was just a metadata, and the predict one is actually, I am selecting from ML predict, I'm naming my model, and this comes where I actually join, I'm naming join with my own data, And this is actually the input, because this is unseen rows, and the system needs to tell me if the unseen rows are actually fit and what's the outcome of the prediction. And here the prediction is actually here. So you have there that predicted label is 1, so they will purchase. And you can see here that they are not from mobile, and they have 14 page lists from United States. This is just a simple example to show you some. You should actually run broader outputs for this. I will explain a bit later how you leverage this output. Now, just assume right now that you have a result and you can do business value from it for that, but I will have slides for later for that. Often people ask me that, I built out things from the questions that I get at previous conferences, that I want per user, so not as a global, you see that didn't have any binary, just a broader scope, I want per user. And I can do per user as well, I can predict using that, and here I'm adding actually group by full visitor ID, and of course I added full visitor ID into the query itself. And this means that I actually added in the user into the equation. And by this, I have actually enabled which users, what the number of predicted purchases are. Which is good, because now I can tell that give me 1,000 users from this list in order to put in an ad, or in order to put in some marketing campaign and so on. Often people, that's why they use machine learning, because they don't know how to pick from 5 million people who are the best targets for that. Think that you are in a big telco company with 8 million customers on your database, and you have a campaign to launch for, I don't know, 10,000 people. How do you select that 10,000 people from 8 million? By random, by using machine learning, actually converting the model and A/B testing this data. K-means clustering. So K-means clustering, actually, you need to combine with the services, because often how you combine services is how you develop your data to get better data. It means that it helps you to actually see customer segmentation. We tend to give names to certain groups, and we need to identify those groups machine learned or mechanically, let's say so that. And of course, the data quality is something that we need to add there, like based on 80% of our database, or based on, often people give me sheets with reports and numbers, and I should believe it, based on what? 100 users, based on 50% of our user base, based on the entire platform, based on the last 2 weeks, based on what? So often they are just numbers there which look good because they created to look good, but it's not actually good business value to the bank. Of course, you can tune the options, because each algorithm has options, and then you actually add here with comma all the options that you can tune on your model. I added some enumeration here that you have also the century. This will be clusters you will see in the chart. And you can also get training info and feature info, which has metadata to actually tune further your parameters, which is just a simple example, having options here, one single item in there. You add different items there to tune your model. Let's define a problem. You know Booking.com, everyone knows. They have a bunch of features, and let's say that they want to improve all their data set. And they will classify all the attributes that the home has into a true-false system. And as you see here, you have different options like TV, pay-per-view channels, bed, shower, telephone, and so on. This will be a large flat table. You can create a model on this, and can apply clustering on the encoded data. Why I say encoded data? Often people don't bridge information like how do I should put that television in a model like as television. That can be classified as a 0, 1 or as a true false, and the system automatically uses the encoded data. Now, this is how the clustering will work. You can read the centroid. You can also detect outliers. And how you use this? Either to name the cluster, to give a name, like these are from, I don't know, Greece, or these are from Italy. You give names and actually makes human sense what you see there. The other example is that you detect outliers. Like, for example, someone mentioned that they have pay-per-view channels in my previous example, but they didn't add a television. And for example, if I'm a guest and I'm searching on the interface, in the filters I put that I want a room with television, and then they don't come back because they only mention pay-per-view. And I can actually give to the homeowner a recommended email that, hey, we detected that you are an outlier, you should revisit your portal and actually add more data to it. I am improving one of my outsider, which actually doesn't give me any value because they are outliers. And when they improve the data, they are coming back and they're giving me business value. Matrix factorization, this is actually my favorite. It's still in alpha, so I'm speaking very, very limited on this topic, but I put out details to understand clearly what this is. For what you use the product recommendation and actually market campaign optimization tool. The previous example, like how to select 10,000 customers from a large base. You need to have as an input 3 things, so you don't need to select here that many columns, you actually need to have 3 columns. User, item, and rating. So what is user? John. What is item? Let's say buys coffee. What is rating? A number. And that number is actually, you need to come up with that number. And in that number, you can always combine different services. You can actually write an equation like how do you create that number. That number can be anything. Let's see in practice, because this is actually to shed the light for you. So you please focus first on the first table, then I will explain what the other table is. So I need to create in SQL a table. Someone told me that this is a pivot table. Indeed, it's a pivot table, but I need to create a table where actually I'm selecting the 3 things, the user, item, rating. What we see here is that John buys fruits, buys sweets, and nothing else. And for example, Jennifer doesn't buy coffee. So I created the table like this. I create the model, and after that, I actually run a prediction. And that prediction, in a simple word, means that assign values for previously unknown values, zeros in our case. What is the business and the use case here? The use case is that I want to see who to send an email marketing email to actually recommend them buying coffee. Because I know who bought coffee, but how should I order the rest of the user? Because maybe I have 10 million users there, and I have budget only for 10,000 users. I need to get out 10,000 users from it, the best 10,000 users from our data set. And actually, this is the prediction in the tabular database. So when I have zeros, later I come up with the prediction, I get numbers for the zeros. Of course, you don't need to see magic, like it's not Superman thing that you receive 90% of numbers here, because it's just a small fraction of it. But you can have an order by, and then you can select that which user is the most recommended to actually fulfill the campaign. Is it clear? Good. How this is practice? In practice is that I create a model, I add a type, and I need to create a select with the 3 columns. Of course, you may say that I don't have rating. That's the only thing that you need to build up. If you have 10 columns, which you can add there, from 10 columns you come up with an equation, which could be very simple at the beginning, and you actually normalize that into a single number. or actually you multiply some services, some values, and so on. Like how many, if they are a logo designer company, like how many saves they did on a specific logo that they still didn't buy. How many time they spent on that logo. And then the logo will come back that it's not bought, so I need to recommend them that, hey, my algorithm shows you that you like this, you should buy it. And I know specifically which one, because I could build out a model from it. I have this select, and this is just this, so there is nothing else there on the model. The second one is actually running the recommendation, and this will return every user I compare. So what people forget actually here that if I have 10,000, if I have 10 million inputs, this actually returns me 10 million results. And it's not interpretable. It's just too much data. You look at, oh, the query syntax is correct. I have results, but it's too much. And the next one is when you combine with a specific user, and you combine that, for example, here on the recommend, you can name John as a user, and you can name here also that I want only those items from my list who the item rating is different than 0. So that means that the different is 0, it means that the John, because it's a single user, John didn't purchase this item. So I'm actually getting from my results the ones with previously was with 0, and now I'm getting back with the non-zero values and ordered by the predict rating. So as a recap, if you try out this service, you actually go back tomorrow, Monday, to your office, you create a CSV file, you upload to BigQuery, you run a model, you run a prediction, and you have an order by how to use and which are the best recommended users. And then you do A/B testing and do the hard work actually to validate that this in real life is actually works or not. And you come back and tune the rating parameter. You probably end up using 10, 15 columns from your data to actually improve the rating model and so on. So rating can be any metric of use, view, visits, purchases, edits, save, whatever word that you set for your platform. You can assign previously unknown values, like that's the recommendation, sorry. And based on the recommendation users, you can order by your system exam. As I mentioned, for 1,000 people, and for example, which customers will likely to buy. So you are answering questions like which customers will likely to buy. Now let's move on a bit with the considerations. So, of course, you need to run this daily. You need to determine hyperparameters which are there, and you need to figure out for your use case. And you need to surface the results. So, if you run the table and you see just the data and you don't put in action, you don't give a life to that, then it's just a try and a sandbox. You need to put in production, and actually you need to see out if that output is actually turning you into purchases and so on. Of course, you need to A/B test, and the net promoter score, how scientists refer to that, is something that you can actually measure how this is actually improving. If you don't have that, you should read on. As I've been to the Cloud Next in San Francisco, I heard a lot of things like the previous slides often were there presented. So let's see what's on the roadmap. So they are adding all kind of bunch of stuff there. So charts, all kind of charts all from your model are on the interface. This is for the advanced users who want charts to see how they are performing and what's the iteration number that, like here in one single iteration, it actually learn the system. Charts again, different charts like the numbers. We can have even the matrix with the color red, like classified correctly and incorrectly. So you get some kind of feedback, of course, on the interface without actually exploring the raw data. Continuing with the alpha, so they added the DNN, which is actually a nonlinear relationship. And what DNN does is that it's improving a clustering system where you have actually 2-3 limited number of clusters. The example here is that from the basketball data set, which is available, like 3-point attempts, and the logistic regression produced this number of predictions, but the DNN model is actually producing 26 and 72. And if you add a basketball fan, you already know that the 3-point attempts, it's not under 32 on a game. The attempt is larger number. And you can figure out that if you have only just 2 classes from it, then DNN is the better algorithm for that. And the favorite, which will come on the market, is that it lets you to add TensorFlow models. So that means that if you have a team that builds TensorFlow models and you want to run that on tabular data, they can build it outside of the platform. You upload it to the Google Cloud Storage. You have here an option to add the path, the zip file or the folder where the model is, and you can use that on the tabular data, which is extremely cool because often people are that, hey, I need a service where I'm inputting a lot of data, the model does thinking, the response is slow, but in the database it's just a query, which is indeed instant, the model creation is slow. I have a demo here, but I cannot run right now. So you can query, you can search on Google like query it smart, sorry, on GitHub, and you will find the demo. And you can play, like, you can select a picture from an example, like a Formula 1 car, and it's returning other cars from your image set. So something like that was the TensorFlow model used for images. And final slides. So BigQuery has its limits, of course. Some services are in alpha. You can have 10 GB of data that's free. It's pretty enough to play with. Often the model is just 25 megabytes. The pricing is expensive compared to terabytes, but if you have already a terabyte data for the model, that means that you can afford the 250. And you are limited to 50 iterations, which may run to like 6-7 hours for that. If you have your data model like running like that, and you have EU zone, so often people ask me if you can do this with EU. Yes, they can, so they can create data set like that. I added this slide because people come into a machine learning section that, hey, I want to learn something new. I want to figure out simple words, not technique, like how should I do machine learning at the job and so on. So often people say that ML is hard, we don't have a dedicated team. But with BigQuery, you don't need a dedicated team. You need only good SQL skills. You can extend your current stack only with BigQuery. You don't need a steep learning curve. You can understand how to connect tabular data and not just audio, video, and others. And you can start using cloud, because often the problem is here that people don't start to open to cloud. But when you have these kind of features, they are much more easier open to the cloud for that. And increase innovation. As a last slide, benefits of BigQuery democratize the use of machine learning, general teams. You need general teams. You can increase innovation, and it's easy to change and recycle. Often with TensorFlow, you work days to actually see the results. by writing a query model, you just need to wait and run again how it works. And it's very easy to recycle options for that. And as a use cases, you have here the possibilities. So you can predict customer value, funnel conversion, you can forecast revenue, you can tailor different experiences for that, and you can even personalize content for gaming and predict player lifetime value. Often you need to have better playing people in a game against. And this concludes my talk. I need to mention that we have IT Mureș as a community, and we run the same community events in our town, and we are looking for speakers eventually for our topics as well. Thank you.